Dear students, I, Mr. Vishal Shah, Assistant Professor, Krishna Institute of Pharmacy, Karad, once again welcome you all to this my YouTube channel. In this video, we are going to learn about the types of different instrumental methods. In previous video, we have seen in detail about the different classical methods that are used for the analysis of pharmaceutical substances. If you have not watched my previous video, then you can watch my previous videos, and also you can subscribe to my YouTube channel to get the more videos related to the pharmaceutical chemistry as well as the pharmaceutical analysis. In previous video, we have also discussed about what is the meaning of instrumental methods, difference or the advantages and limitations of these instrumental methods. As we know that instrumental methods are having more accuracy, precision, that's why they are generally used as well as applicable for sample which is having very small quantities. Even in nanogram, picogram, we can carry out the analysis of such a substance with the help of the instrumental methods. But these instrumental methods are having different types. So these types we are going to discuss in this video. So let's begin our today's session. Before that, just we will see what are the learning outcomes, means what you should understand after watching my this video. After this session, students will be able to explain the different types of instrumental methods. So you should be able to tell which are the different types of instrumental methods are there. So let's reveal that which are the different instrumental methods. Basically, there are 4 different types of instrumental methods are there. So many techniques are available for the analysis of analytes. Here you can remember analyte means the sample that is to be analyzed. That is known as the analyte. So whatever analyte is there, the analysis of that analyte is carried out by using so many techniques. It depends upon which type of information is required for us, and depending upon that we are going to select the type of instrumental method that can be used. यहाँ पे आपको समझना है analyte means what, जो substance जिसका analysis करना है उसको हम analyte बोलते हैं. और एनालिसिस करने के so many methods अवेलेबल है, टेक्निक्स अवेलेबल है, उसमें से हमको स्पेसिफिक टेक्निक चूज करनी है डिपेंडिंग अपॉन द टाइप ऑफ इंफॉर्मेशन. जो इंफॉर्मेशन हमें चाहिए उसके हिसाब से हमें टेक्निक चूज करनी है. एज आई सेड, देयर आर 4 डिफरेंट टाइप्स ऑफ एनालिटिकल टेक्निक्स आर अवेलेबल. फर्स्ट वन इज द इलेक्ट्रोएनालिटिकल मेथड. Then second one is analytical separation method. Third one, analytical spectroscopic method, and last one is the miscellaneous method. Now just I will tell you in small what is the meaning of these 4 methods. First of all, just you can remember which are these methods. One is the electroanalytical method. Now all these methods are based upon the analytical principle, that's why they are known as the analytical methods. Now in case of electroanalytical methods, we will be measuring either current, potential, that is the chemical potential, and they are majorly based upon the electrons that are present in that particular analyte, or as I said, substance that is to be analyzed. So here that's why the name electro is used, because it depends upon the electrons that are present in our sample. These methods are known as the electroanalytical methods. Now, second method is analytical separation method. Separation means what? As we know that the various substances or a compound are consisting of various mixtures, and if we want to carry out the separation of this individual component, then these techniques that are used, which are known as the analytical separation methods. These are based upon the chemical equilibrium. means the concentration of one substance into one phase. This is known as the equilibrium. And detectors are employed in this particular analytical separation methods to detect what is the chemical nature of that particular compound. So this is about the analytical separation method. Like say example chromatography. Chromatography techniques are nothing but the analytical separation methods where with the help of the chromatography we can carry out the separation of the mixture into its individual components. Means क्रोमेटोग्राफी टेक्निक में अगर हमें कोई मिक्सचर होता है कि जिसमें 4 to 5 या मोर देन 2 कंपोनेंट्स है, बाय यूजिंग दैट क्रोमेटोग्राफी टेक्निक हम जो भी इंडिविजुअल कंपोनेंट है उसे सेपरेट कर सकते हैं. दैट्स व्हाई दे आर नोन एज द एनालिटिकल सेपरेशन मेथड्स. देन one of the most important method that is used for the instrumental or type of the instrumental method is analytical spectroscopic method, that is based upon the chemical energy of that molecules as well as the photons. Photons means what? Energy that is eliminated or absorbed by that particular substance either in the ground state or the excited state. So various spectroscopic methods are useful in the determination of the structure. Suppose I am having a powder of XYZ drug. So with the help of that analytical spectroscopic techniques, we can determine the structure of that particular individual component, not a mixture. So if you have any pure substance, we can determine the structure of that particular pure substance by using the analytical spectroscopic method. So that is the use of these analytical spectroscopic methods, and few miscellaneous methods are there that we will discuss at the time of our lecture. So these are the various types of instrumental methods that are available. Now we will see in this video we are going to discuss only electroanalytical methods, and just we will see introduction about the analytical separation methods. In next video in detail we will discuss about the analytical separation methods. Now, electroanalytical methods. As I said, electrochemical methods or electroanalytical methods are powerful and versatile analytical techniques that offer high sensitivity, accuracy and precision with relatively low cost of the instrumentation. These are the, you can say that these are the techniques which are very superior to the classical methods that we have seen, like volumetric analysis as well as the gravimetric analysis. Now first technique that we are going to discuss is potentiometry. Potentiometry is useful means of characterizing an acid of which the potential is measured across the analyte without using indicator. Now we know in a volumetric analysis we are going to use the indicator to indicate the completion of the reaction. Similarly, here there is no need to use such indicators to check whether the reaction is complete or not. In this potentiometry, we are going to use different electrodes, and these electrodes are dipped in the sample solution, and depending upon the component of that particular solution, means the ions that are present, they will show different potential, and by using this change in the potential we can identify whether the reaction is complete or not. So this potentiometry gives information about the composition of the sample through the potential that is appearing between the two electrodes. This is the typical diagram of potentiometer. Here generally pH potentiometer are combined instruments that nowadays are coming. This is the electrode which is dipped in the solution, and it gives us a display of different potential that is present across this particular two electrodes, and by judging this potential we can identify whether the reaction is complete or not. This is generally applicable for the acid-base titration reactions. Then second type of the electroanalytical technique is voltammetry. This is rather very generally used. Voltammetry is the study of current as a functional of the applied potential. Like in potentiometry, we are going to use the measurement of potential. Here we are going to carry out the measurement of the current. It is used to designate the current voltage measurement that is obtained at a given electrode. Means here, with the help of this particular instrument, we are going to measure the current voltage that is applied across the electrode. Then coulometry. Coulometry used for the determination of amount of matter that is transferred during the electrolysis reaction by measuring the amount of electricity that is consumed or the produced. As we know, the unit of the current is coulombs. So this is the technique where we can study the rate of electrolysis reaction. So specifically it is used Karl-Fischer reagent, where we can determine the amount of water that is present. This is the typical example of coulometry, which is used for the determination of electricity that is consumed or it is produced. Polarography. This is also one of the important technique, which is the special case of voltammetry, referring to the current voltage measurement acquired using dropping mercury electrode with a constant flow of mercury drop. Here in polarography, we are going to use the dropping mercury electrode as a reference electrode. So whatever these techniques are there, these techniques are majorly consisting of two electrodes. One is the reference electrode and indicator electrode. So here that reference electrode that is used is the dropping mercury electrode. This is the typical diagram of the polarography. Then amperometry. In amperometry, we are going to use it for the determination of any analyte concentration by measurement of current that is generated in a suitable chemical reaction. So this is the typical diagram of amperometry. Now, this is also one of the important technique as compared to the potentiometry. So whatever the techniques that we have discussed, conductometry and potentiometry, these are the two very important techniques which are frequently used for the electrochemical analysis. Conductometry is measurement of electrical conductivity of ionic solution, means conductance is measured. It is the conductance is measured in the ionic solution by applying an electric field between two electrodes. Conductance is nothing but it's a reciprocal of the resistance. This is the typical diagram. Here also we are going to use the different electrodes, and these electrodes are dipped in the sample solution, which indicates the color. Depending upon different ions that are present in the solution, conductance can be varied. Then electrogravimetry. Electrogravimetry is based on the analysis that is carried out by passing an electric current for a sufficient length of time to ensure complete oxidation or reduction of analyte to give a single product of known composition. So this is about the electrogravimetry technique. So these are the various electrochemical techniques. This method is used to separate the quantify ions or substance, usually metal complexes like nickel, calcium, zinc, cadmium, etc. Then we will discuss about the analytical separation methods. As I said, chromatography is a method of separating a mixture of compounds into individual compounds through equilibrium distribution between two phases. Here you have to remember that we are going to use a stationary phase and mobile phase. These are the two important phases. Chromatography is based on the difference in the rate at which compound of a mixture moves through a porous medium under the influence of some solvent or the gas. Chromatographic methods broadly classified on the basis of separation takes place on a planar surface or in a column. In column chromatography, the stationary phase is placed in a narrow column through a mobile phase moves under the influence of the gravity. In planar chromatography, the stationary phase is placed on the flat glass surface and the mobile phase is placed in the chamber. Depending upon the stationary phase used, chromatographic methods are broadly divided into two types: adsorption chromatography and partition chromatography. So in detail we will discuss in the next video.